All right, George. I have my picture of your review on my iPad, so I'm going to kind of talk you through some of it. The first one asks you to categorize each quantity as being either a vector or a scalar. So you just need to remember the definition of a vector. A vector has magnitude and direction. And so that means you have to give it a number value, and you have to attach the direction to it to completely describe this vector quantity. A scalar has magnitude or size only. All right. So if you look at those choices that they give you, it looks like to me I see 1, 2 in the first column that are vectors, and 3 in the last column that are vectors. All right. What is the distance and displacement of the race car drivers if they drive 10 laps on a 1-mile circular track? Well, every time they go around, they're doing 1 mile, so their distance is going to be 10 miles. But the displacement is their change in position from beginning to end. So it seems to me that if you're on a circular track, you're going to come back to where you started from, so you have 0 displacement. All right? And then number 3 says, Tim frequently paces back and forth on his way to class. The diagram below shows several of Tim's positions at various times. At each marked position, Tim makes a U-turn and moves in the opposite direction. In other words, Tim moves from position A to B to C to Z. What is his resulting displacement and distance? So if he goes from A to B to C to D, it looks like to me he's displaced himself 60 meters, because he began at position A and he ended at position D, which is a distance of 60 meters. So he's now 60 meters, or 10 meters past the origin. No, I'm sorry, 5 meters past the origin might be a way to say it. So 55 would have been better answer than 60. So his displacement is 5 meters past the origin. And then we have to look at what he does distance-wise. So he goes from A to C, which looks like it is 15 meters. And then I guess he goes back to A. I don't know, this is pretty confusing. So if he goes back to A, that's, yeah, I'm not following what he's doing at all. Goes from A to B to C to D. Okay, A to B. So A to B, his first change in first distance would be, looks like 35 meters. And then he goes to C, so he moves another 20 meters. So now he's got a distance of 35 plus 20 is 55. And then he goes from C, which is at 35, to D, so he goes another 40. So if I added up those 3, I would get his distance, and I just forgot what numbers I said, so let's see. So A to B was 25. Oh, I'm sorry, A to B was 35. And then B to C was 20 more, so we're at 55. And then C to D we said was 40. So 55 and 40 is 95 meters for his distance. All right. So I'm going to pause there, and then I'll pull up the next one. Okay, so question 4 says, explain the difference between distance and displacement. Well, first of all, distance is a vector quantity and displacement is scalar. So when I look at distance, I just look at how many feet or meters have been traveled from beginning to end. When I look at displacement, I look at how his position changed from beginning to end. And I always make a reference from where he began to where he ended and give the direction. So if I walked out 10 meters to the east and I stopped, my displacement would be 10 meters to the east. If I walked out 10 meters to the east and then went back 5 meters to the west, my displacement would be 5 meters to the east. So make sure you put a direction on your displacement. We have a child pushing a shopping cart at 1.5 meters per second. How long will it take this child to push the cart down an aisle with a length of 9.3 meters? Well, that one's pretty straightforward. You know that the distance, our average speed, is distance over time. Average speed was the 1.5 meters per second. And That was our average speed. Our distance was 9.3 meters. We wanted our time. So time is equal to distance divided by average speed. So I would have had 9.3 meters. Notice I'm putting units on every number over 1.5 meters per second. Those will cancel. And so if I've done my math correctly and I punch in 9.3 divided by 1.5, I should get the same answer that the teacher gave you, assuming that that answer is correct, of 6.2 seconds. All right. Then we look at number 6. Refer to the above diagram to answer the following questions. In which section was the car traveling at a constant negative velocity? That looks like it's section E to F, if I can read those letters correctly. In which section was the car at rest? Well, it looks like it was at rest from C to D, and it also stopped for a bit of time at G because it went to, no, that's not true. Let me go back and do that again. I didn't pay attention to the position. In fact, it was position. I thought it was velocity, so all of my answers are wrong. Let's go back and do them again. So 6A, in which section was the car traveling at a constant negative velocity? You're looking for a negative slope. Okay. All right. B says, in which section was the car at rest? So you look for no change in position. C said, what is the total distance traveled by the cart? So you look at each of the individual distances traveled and add them up and don't pay attention to the sign. What is the total displacement of the car? Same thing that you did on C, but you have to pay attention to the sign. And then on the graph, sketch the velocity versus time graph. Well, you look at the first one. From A to B, there is no velocity. B to C is a negative velocity, a negative slope. So take that slope. It looks like it would be a rise of, or a fall basically of 10, negative 10, over 2 seconds of time. No change in position from C to D, no velocity. Negative, then you take the slope from D to E. E to F, no position, no velocity. F to G and G to H are both positive slopes, so take those and then just plot your graph. All right. So that takes us through number 6. So I'm going to go back and do another one. Okay, number 7 says refer to the diagram above. Okay, this time it is a velocity versus time. It's odd. It's in meters per minute, which is fine. Okay, it says refer to the above diagram to answer the following questions. Briefly describe its behavior between 10 and 15 minutes. Well, it looks like it's maintaining a constant velocity. And then they want to know what its average acceleration would be 0 because it is not accelerating. During which time interval did it travel in a positive direction? So look for your positive slope. So I would say from 0 to 10. And then it looks like to me that from 40 to 55 maybe, it's headed away from the negative position back toward the origin, so it's changed direction, so it must be headed in the positive direction there. Average acceleration between 15 and 30 seconds. So find your acceleration from 0 to 10 minutes, and then from 15 to 30 minutes, and take the average of those two is what I would do. What is the total displacement of the cart, area under the curve? And on the graph, sketch an acceleration versus time graph for the cart. So from 0 to 10 seconds, you had a positive change in velocity. From 15 to 30, you had a negative slope. 30 to 40 had the same negative slope, so you would take that and get a negative acceleration. And then 40 to 55, you would calculate that and get a positive acceleration. And then from 10 to 15, you would have 0 acceleration. Okay, so you should be able to sketch that. Athlete swims from the north end to the south end of a pool, 20 seconds. Goes back in 22 seconds. What is average velocity for the first half of the swim? Well, you know distance over time, so that one wasn't too bad. And you need to say that he was headed to the south. All right, so let's see what I can do here. And then the last one that you gave me says C and D are B and C. What is the average velocity for the second half of the swim? So he went to the north 50 meters, and it took him 22 seconds. So you can do 50 meters divided by 22 seconds, and that would give you the 2.27 meters per second, and he's headed to the north. And average velocity, well, his displacement was 0 because he stopped where he started, so it would be 0 meters divided by 42 seconds, or 0 meters per second. Okay. Number 9 says two students walk in the same direction along a straight path at a constant speed, one at 0.9 and one at 1.9. Assuming they start at the same point and the same time, how much sooner does the faster student arrive at the destination 780 meters away? All right, so I'm going to pause and do a little bit of math and get that for you. All right, so we're going to look at the faster student. So the faster student has to go 780 meters. And the faster student is moving at 1.9 meters per second, so that's the distance. The speed is 1.9. And we'll find the faster time by saying distance over speed, average speed. So 780 meters over 1.90 meters per second. And the time for the slower dude is still 780 over 0.9 meters per second. So find the time here and here, and then take the faster time minus the slower time, and hopefully you'll get that 460 seconds that your teacher was talking about. Okay? How far would the students have to walk so that the faster student arrives 5.5 minutes before the slower student? All right, so let's take a look at that. So we know that they're both going to go the same distance, so the distance of the slower equals the distance of the faster. But you want the time of the faster minus the time of the slower to be 5.5 meters per second. Oh, no, I got it totally wrong. I said part B asked how far they would have to walk. All right, so let me stop and think about that, and then I'll come back and show you what we need to do there. My bad. Sorry about that. All right, so here's what I did. They are both going to go the same distance, so that's good. So the distance of the faster has to equal the distance of the slower. And then I said, well, the time of the faster has to equal the time of the slower plus 3.5 minutes, I think it said. Let me look at it again. Plus 5.5 minutes. So 5.5 minutes is the same thing as 330 seconds if I did that math correctly. Yeah, so there's 330. So whatever this dude's time is, plus 330. Okay? So then I brought this over to the left-hand side, and I got a common denominator. The only problem I'm having is this comes out to be a negative, and you can't have negative time. Now, if I finish this out, then x is going to be 564.3, which is your 570 that your teacher gave you. So I'm a little bothered by the fact that I have a negative sign there. So you might want to ask a question about how I got a negative sign, because that's kind of goofy. All right, then let's look at the last couple of ones. Number 10 says a flower pot falls out of a windowsill 25 meters above the sidewalk. What is the pot's velocity just before it hits the ground? All right, so we know that VF squared equals VI squared plus 2AD. If it falls, this is 0, and you know A is gravity, and you know D is the 25 meters, so it shouldn't be hard to get the final speed. And then it says how much time does a person on the sidewalk have to get out of the way? Well, you have this equation, which is what I would pick. And I would know this is 0, and I know my distance and my acceleration, and I could find my time. You could also do VF equals VI plus AT. Because you have this is 0, you just calculated this, you know that, and you should get the time. You should get the same answer either route you take, okay? All right, then a ball is thrown vertically upward with a speed of 25 meters per second for a height of 2 meters. How long before it reaches the highest point? All right, so I have VF squared Not what I want. So I'm probably going to have to do two equations. I can do d equals 1/2 at squared plus vit. Now, as long as I realize there's symmetry in the situation, it goes up as far as it comes down, then I can say, well, let me look at it on the way down because it has the same behavior as it does on the way up. I know this distance. I know this acceleration. If I talk about it on the way down, at the highest point, vi is 0. So I can use that value there. That's also BF on the way up. All right? So as long as it's symmetrical, then I can use this equation. If you don't like to do that, then you can say, well, BF equals BI plus AT. And you know the VF is 0 at the highest point. You know the VI was the 25 and the A was your gravity, 9.8. I would use negative because it's on the way up, but that's me. And you could solve for time like that. And then it says how long does it take for the ball? Oh, no, we're fine. Okay, so that's good. All right, but this one won't work because it's not a symmetrical situation, so don't do that. I didn't read it carefully. It tells you that it starts at 2 meters above the ground, so it's got to fall those additional 2 meters to get back to the ground. So that's not cool, what I did right there. So there's the time up. Now the time down won't be equal to that because it has to fall 2 more meters to the ground. So now let's talk about it falling down. So that was the time up. So on the down, we have to figure out how high did it go up, and then add 2 meters to that, and that'll be the distance it has to fall down. And then once we know that, we can say d equals 1/2 at squared plus vit. Because now we'll be talking about it falling down. You have to read carefully. Even though I didn't read carefully, you need to read carefully. Okay, so let's find the distance up. Well, we have vf squared equals vi squared plus 2ad. So we know that this will be vf squared minus vi squared over 2a. And that'll give us the distance that it went up. Okay, so we know that the VF is going to go to 0. VI was 25. So I would say 25 squared divided by 2 divided by 9.8. And I would get 31.89 meters. That would be the distance that it went up. And I would add 2 meters to that to find that it fell 33.89. And then I would apply this equation here, because I know this, and I know A, and I could get the t that it falls. And it's going to be a little bit more than the t that it rises, because it fell down a little bit more. All right, 12 and 13. So let's move on to 12 and 13. 12 says a car traveling 22.4 meters per second comes to a stop, 2.55 seconds. Find the skidding distance of the car. So I would do VF equals VI plus AT. And I would know that this is 0. This is VI is 22.4. A would be my acceleration that I need to find, and my time would be 2.55 seconds. So I would find my negative acceleration, and it would be negative 22.4 divided by 2.55. And I would get a negative 8.78 for my acceleration, but you better check my math, make sure I'm not lying to you. And then once I knew that, I could do VF squared equals VI squared plus 2AD. Rearrange this and solve for D. So D would be VF squared minus VI squared over 2A. And I could solve for my distance. All right, last one. Bullet leaves a muzzle rifle with a muzzle velocity of 521 while accelerating. It moves a distance of 0.8. Find the 0.84. Find the acceleration. Well, that's no big deal. You have VF squared equals VI squared plus 2AD. We want to rearrange this and solve for A. So A is going to be VF squared minus VI squared over 2D. VI is 0 because it had no velocity before it was shot. You know this is 521 for the VF. Don't forget to square it. And it traveled 0.84 meters. So solve for your acceleration. So hopefully you'll get 1.62 times 10 to the, maybe that's a 3 meters per second squared. Okay, buddy, hope I've helped.